Welcome to this session on sugars. In this session, we will learn about different types of sugars available in the market, understand the manufacturing process of sugar and to know the uses of sugar in cookery. Sugars are crystalline substances which are monosaccharides or disaccharides, water soluble and sweet compounds. The sugar that is used for food preparation as a sweetener is pure refined sucrose extracted from sugar cane or sugar beet. In all the fruits and vegetables too, sugar is found in the form of sucrose, a disaccharide. The sugar separated from sugar cane and sugar beets is exactly the same as the sugar found in all fruits and vegetables. The sugar processed from either sugar beet or sugar cane is identical in all aspects and may be used interchangeably for all purposes. All green plants manufacture sugar through photosynthesis, the process by which plants transform sunlight and soil nutrients into their food and energy supply. Sugar consumption in India is said to increase marginally to 27.2 million metric tons in the year 2016-17. Growing domestic demand for sugar is expected from soft drink manufacturers, bakeries, hotels, restaurants, confectionery and ice cream manufacturers who predict higher consumption. Bulk consumers account for about 65% of the total sugar consumption in India. India's economy, political situation, rising incomes, young population and changing consumption pattern are key drivers for food consumption. Most Khansari sugar is consumed by local sweet shops and gur is mostly consumed in rural households and for feed use. Sweets made from sugar induce a sense of satiety. Sugar is better consumed along with foods containing other nutrients such as protein, fat and carbohydrates. As for the composition of sugar is concerned, sugar is almost a pure sucrose, a disaccharide made up of glucose and fructose. 1 gram of sugar supplies 4 kilocalories of energy. The yield of jaggery from sugar depends mostly on the quality of the cane and efficiency of extraction of juice. High quality cane has a good juice content with high sugar levels around 20% or more. Poor quality cane or cane that has been harvested early may have similar juice content, but the sugar levels will be reduced. The efficiency with which juice can be extracted from the cane is limited by the technology used. The simple 3-roller crushers used by most traditional methods will never extract more than 50 kg of juice from each 100 kg of cane. Yields are also improved by careful control of the boiling process. Boiling should be completed as rapidly as possible and the conditions are to be kept as clean as possible. Various forms of sugar are available for use in food preparations. Some forms are crystalline solids and others are liquids, also called as syrups. Sugars are classified based on the form into granulated sugar, cube sugar, powdered sugar, brown sugar, rock sugar, diamond sugar, molasses, sanding sugar, turbinado sugar and demerara sugar. Granulated sugar is most extensively used in food preparation because of its sweetness, color and solubility. Some of these are used only by the food industry and professional bakers and are not available in the supermarket. It is available in different granule sizes. Each granule size provides unique functional characteristics that make the sugar appropriate for a specific food's special need. Cube sugar is granulated sugar moistened with white sugar syrup, molded into cubes and then dried in that shape. The cubes are convenient for sweetening tea and coffee. Powdered sugar is made by pulverizing granulated sugar with or without the addition of any edible starch. Starch, if added, absorbs moisture and prevents the caking of powdered sugar. Powdered sugar is mostly used in confectionery for dressing cakes, pastries and other bakery products. Brown sugar contains some of the molasses from which the crystals are separated, and some glucose and fructose, some flavor substances are present in brown sugar. Because of its pleasing and distinctive flavor, brown sugar is frequently used in baked products. The darker sugar has more flavor than a light sugar. Brown sugar forms lumps during storage. To overcome this difficulty, liquid brown sugar is now available in the market. Rock sugar is made by boiling sucrose solution to a sugar syrup consistency at 110 degrees centigrade to 115 degrees centigrade and pouring it into big trays. Due to slow evaporation that takes 3 or 4 days, the sugar syrup forms big slabs with a few lumps on it. This is broken into big pieces and used generally on festive occasions. Diamond sugar is a decorative sugar in small rectangular crystals. It is used with betel nuts and in other confectionery. Molasses is a dark colored syrupy product resulting after the removal of crystalline sucrose by centrifugation from the concentrated clarified cane juice. It amounts to about 3.6 to 4.5% of the cane crushed. In India, molasses is obtained as a byproduct chiefly in the manufacture of direct consumption white sugar. It is also used as a flavoring agent in hookah tobacco for feeding cattle and indirectly in the manufacturing of vinegar and yeast. Molasses contains not more than 25% water and not more than 5% mineral ash. After the first crystallization of sucrose, the molasses is high in sugar and light in color. After the final process, a dark and bitter product with relatively high mineral content called blackstrap molasses remains. Sanding sugar is a type of large crystal sugar. Sanding sugar is used mainly in the baking and confectionery industries as a sprinkle on top of baked goods. The large crystals reflect light and give the product a sparkling appearance. Turbinado sugar is raw sugar which has been particularly processed, where only the surface molasses has been washed off. It has a bland color and mild brown sugar flavor and is often used in tea and other beverages. Demerara sugar is a type of sugar popular in England. Demerara sugar is a light brown sugar with large golden crystals. These crystals are sticky from the adhering molasses. It is often used in tea, coffee or on top of hard crystals. Other types of sugars available are glucose or dextrose, fructose or fruit sugar, galactose, sucrose or cane or beet sugar, lactose or milk sugar, maltose or malt sugar. Let us now understand the manufacturing process of sugar. Sugar is mainly manufactured from cane sugar in the tropics and sugar beets in the temperate regions. Sugarcane is the chief source of sugar. Sugarcane belongs to the genus Saccharum, which is a tall, giant, perennial grass and looks like a bamboo. The canes are cleaned and are crushed to extract the juice from the cell sap of sugarcane. The juice is purified by boiling and lime is added to it to precipitate the impurities. Some impurities float on top. After removing the impurities, the sugar solution is concentrated by evaporation under reduced pressure. Molasses is separated from the process and is used to manufacture industrial alcohol. The concentrated sugar solution is passed through a bed of charcoal to get clear liquor, which is concentrated by evaporating the water under reduced pressure to get fine, clean, white, uniform sugar crystals. This process is known as crystallization, which is a major operation in sugar manufacture. The crystals are separated by centrifuging. The leftover syrup is used to make brown sugar. The industrial process for sugar manufacturing involves the application of several processes to transform sugarcane juice into crystals and clean them naturally from impurities that can harm the organism. The manufacturing process consists of the following sub-processes: receiving the raw material, milling, clarification, evaporation, crystallization, separation, refining, drying and packing. Receiving the raw material is the first step in sugar manufacturing. It starts by weighing the units on a scale that transports the sugarcane in the mill. Also, this is where the quality of raw material is determined, taking samples that are analyzed continuously in the quality control lab. The sugarcane that arrives at the manufacturer is discharged on the feeding tables through sugarcane rotators with a capacity of 50 metric tons. To have a cleaner process in the sugarcane tables, water is applied between 110 and 120 degrees Fahrenheit for washing, removing solids or foreign matter like soil, salts, minerals, stones and others that are adhered to the sample in the soil when lifted to the cages that transport the same to the manufacturer. Then the sugarcane undergoes a preparation process that consists of breaking and removing fiber from the stem cells through clippers, oscillating mincers and fiber removers to proceed with the juice extraction process. The next step is milling. Milling is a continuous process that is carried out in the 3 mill tandems. The prepared sugarcane is fed into those tandems which undergoes a series of extractions using roll mills. To make the mill process more efficient, the poor juices of the subsequent millings are reprocessed and hot water is applied in the last milling at a temperature between 155 and 179 degrees Fahrenheit to increase the extraction. The bagasse is an industrial product that is transported towards the boiler system to use it in its biomass state as fuel. The remaining is used for the hydrolyzation and reserve to cover emergency stops. Clarification is the next step. The juice derived from the mills goes through heaters that reach temperatures between 140 degrees and 155 degrees Fahrenheit. Then it goes through the sulfation tower, decreasing the pH to produce only white sugar. In this phase, sulfur is used as a bleaching agent. Then the juice is neutralized with lime. The next step is to feed the juice into the clarifiers slowly to allow sludge concentration and extracting the same by gravity. Evaporation is then carried out in evaporators, in which the vapor and juice are found in separate chambers that flow in the same direction. The juice goes from one evaporator to another through pumping action. The next step in sugar manufacturing is crystallization. The sucrose crystallization or growth that contains syrup is carried out in vacuum containers. This cooking, according to its purity, will produce raw sugar and white sugar. This is a delayed process that is accelerated industrially, introducing a few microscopic grains of sugar known as seeds into the container. Separation of sugar crystals is done next. The sugar crystals are separated from the honey left in the centrifuges. The honey passes through the fabric. The crystals are trapped within the centrifuges and then washed with water. The honey is then returned to the containers or used as raw material for the production of alcohol in the distillery. The sugar is then transferred to the drying and cooling process. Refinement is the next step. For the production of refined white sugar, there is an additional process that uses standard white sugar or raw sugar as raw material. In this process, sugar at 60 Brix degrees is dissolved. Then activated charcoal and diatomaceous earth is added. This sugar undergoes a first and second filtration in vertical filters until obtaining clear liquor. The liquor is evaporated and the crystallization process is initiated. After refinement, drying is done. In the centrifuge process, condensate water is used to wash sugar, which results in a humidity between 0.3% and 0.6%. Therefore, it is necessary to pass it through the drying process to reach levels between 0.2% for raw sugar and 0.3% for white sugar. Packing is the last step in sugar manufacturing process. The produced raw sugar goes directly from the dryer to the storage warehouses. In the warehouses, it is loaded in trucks and the same is transported to faraway distributors. Sugar can also be manufactured from sugar beets. Beet sugar is produced in a one-stage process from beet to refined sugar. Unlike cane sugar, in many cases is produced as raw sugar, which is then refined. Sugar present in beet is extracted by membrane diffusion operated on the counter current principle using the batch system or a continuous diffuser. The thin juice obtained from the diffusion process is heavily limed and carbon dioxide is passed. The precipitate formed is quickly filtered off and carbon dioxide is again passed through the clear filtrate to precipitate residual lime salts. This is followed by a second filtration, after which the carbonated juice is treated with sulfur dioxide. The sulfated juice is boiled to drive off obstructed gas and again filtered to remove all the precipitate. The purified thin juice is processed to the refined sugar product in much the same manner as the process used for making refined sugar from sugar cane. Sugar can be stored in dry form as crystals or in liquid form as syrup. Sugar from beets or sugar cane, corn and honey are most commonly used for long-term food storage. Sugar is stored in a cool, dry location and not in the refrigerator. Moisture makes granulated sugar hard and lumpy. Once this happens, it creates problems in usage and there is no easy method to restore lumpy sugar. Always sugar has to be stored in an odor-free area. Sugar can absorb strong odors even through plastic packaging. Sugar syrup should not be allowed to get too hot or freeze. This will encourage crystallization. Heat will also darken color and alter flavor in sugar syrups and honey. Storage containers should be opaque, airtight and moisture or odor proof. The typical retail paper package for sugar crystals is not suitable for long-term storage. Polyethylene bags, food grade plastic buckets, glass jars are all suitable for dry sugar storage. Removing oxygen for long-term sugar and honey storage is not required and not recommended. Honey is slightly acidic. It will cause rust in metal containers or on metal lids. Now let us understand the behavior of sugar during cooking process and how those properties are made use of in preparation of a variety of dishes. When sugar is heated to a temperature of 110 to 112 degrees centigrade, sugar spins a 2-inch thread between thumb and first finger. At 112 to 115 degrees centigrade, sugar syrup forms a ball when dropped in cold water and the ball flattens on removal from water. That is called a soft ball stage. At 118 to 120 degrees centigrade, sugar forms a syrup which when dropped into very cold water forms a ball that does not flatten on removal from water. This is called firm ball stage. At 121 to 130 degrees centigrade, when the syrup is dropped into cold water, it forms a ball that is hard enough to hold its shape. This is called hard ball stage. At 132 to 143 degrees centigrade, when the syrup is dropped into cold water, it forms threads that are hard but not brittle. At 149 and 154 degrees centigrade, when the syrup is dropped into cold water, threads that are hard and brittle are formed. At 160 degrees centigrade, the sugar liquefies, and at 170 degrees centigrade, the liquid becomes brown in color. This stage indicates caramelization of sugar. Sugar has many uses in cookery. Sugar is used as sweetening agent in ice cream and beverages like coffee, tea, cocoa and milkshake. Sugar lowers the freezing point, which is important in making ice creams. Sugar is the major ingredient responsible for product shape and structure of confectionaries. Sugar is used in the form of syrup in traditional Indian sweet preparations like gulab jamun and rasagulla. Sugar is used in making bread to increase the fermentation of yeast. Caramel sugar is used in puddings to improve color and flavor. The property of crystallization of sugar is used in preparation of sweets like badusha and laddu and in preparation of fondant and fudge. Sugar improves color and antioxidant activity by Maillard reaction. When used in high concentration, sugar prevents the growth of microorganisms. This principle is used in preserving jams and jellies. Sugar supplies energy to our body. Each gram of sugar supplies 4 kilocalories of energy. Sugar can be metabolized quickly to meet energy needs of our body. Sugar adds bulk. Sugar gives not only sweetness but also body to products like jam, pudding, fondant and ice cream. Sugar helps in improving texture of cake and confectionery. Sugar is commonly added to extruded products, particularly breakfast cereals as it contributes to binding, flavor and browning characteristics that is important in controlling texture and mouth feel. Sugar can act as a carrier and potentiator of other flavors. Sugar aids in the preservation of products in which it is used. The high osmotic pressure of sugar creates conditions that are unfavorable for the growth and reproduction of most species of bacteria, yeast and molds. Artificial sweeteners are low calorie or calorie free chemical substances that are used instead of sugar to sweeten foods and drinks. These sweeteners are as sweet as sucrose and some are sweeter than sucrose. They have pleasant taste and no aftertaste, colorless and stable. They are non-toxic and do not cause any metabolic abnormalities when used in permissible quantities. The sweeteners are classified in the following way based on the relative sweetness, origin and calorific value. Caloric sweeteners such as sucrose, fructose, glucose, lactose, invert sugar, caramel and high fructose corn syrup. Number 2, low calorie sweeteners such as sorbitol and mannitol. 3, non-caloric synthetic sweeteners such as cyclamate, A-sulfame K, allitame, aspartame, saccharin and sucralose. 4, non-caloric natural sweeteners such as steviosides. The sugar substitutes are additives that give sweetness to food and at the same time do not contribute to energy. They may be natural or synthetic. The sugar substitutes are used in foods aimed at weight loss, safeguard teeth, for diabetics and to prevent reactive hypoglycemia. In this session, we have learnt about the different types of sugar, how sugar is manufactured from sugar cane and sugar beet, uses of sugar in cookery and also about artificial sweeteners and sugar substitutes. Thank you.